Hey folks, I want to talk to you about dividing polynomials in this YouTube video, so let's go on and start with the targets. Alright, so we're here, and the target is that you can divide polynomials, but there's some vocabulary that's important here. The factor theorem is where if the factor x minus a, if that part right there, is a factor of the polynomial, that's true if and only if, so it works both ways here, if I plug in that a value and I get a 0, okay? The other one here is the remainder theorem, and that means that if we have our function, we divide by x minus a, the remainder is going to be whatever it is if we just plugged a right into the polynomial. If we just plugged a right in, that's what's going to be our remainder, which is kind of cute. It's useful sometimes. Synthetic division, that's a method where we're dividing a polynomial and a linear function, but it only works in some special cases. We really have to make sure that this is actually of the form 1x minus a, and that's the only way that this works. It doesn't work any other form, so that's why we show the long division way first. So let's get started with that. All right, so we're here. Let us do this the old school way with just the numbers and everything, no calculator. Let's do some long division here. So I have now this 5. And I'm going to put underneath our little division symbol here the rest of that, the 1, 2, 3, 4, 5, and 6. And now I'm going to see how many times does 5 go into 12. Well, that's 2 times. And then I take that 2 and I multiply to that 5 and I get 10. Then from there I'm going to subtract this stuff. So I'm actually going to write this in parentheses every time, and I'm going to subtract straight down. And I get 12 minus the 10 is 2. And then all of these other numbers are just going to come straight down. So 3, 4, 5, 6. Then, how many times does the 5 go into the 23? That's going to be 4 times. And the 4 times that 5 gets me 20. And then again, I subtract this. I wrap that all up in parentheses, and I subtract it away. And I get 3, 4, 5, 6. And I just keep going with this. 5 goes into 34, almost 7 times, but instead it's just 6. And then from there, I need to take that 6 and multiply to that 5, and I get 30. And wrap that up in parentheses, subtract it, and I get 4, 5, 6. Well, that ends up going in 9 times. 9 times that 5 gets me this 45. I wrap it up in parentheses and subtract it away, and end up with 0 from that, and then a 6. And then 5 goes into the 6 one time. 1 times 5 gets me 5. And then I have to subtract that away, and I'm left with a remainder of 1. All right, so here we're going to do some long division with polynomials, and I need to set all of this up correctly first. So I'm going to draw my little shape here, put my x cubed minus 6x squared plus 11x minus 6 underneath, and I'm going to put this chunk here off to the left, so the x squared minus 4x plus 3. And now I'm going to take this first piece and see how many times does it go into x cubed. Better yet, I guess, x cubed, and I'm going to divide it by x squared. So if I have x cubed over x squared, that's an x on top and an x on bottom. Now, one of those on top cancels with one of those on bottom, and then another one on top cancels with another one on bottom, and I'm left with one on top. So that's just an x. I'm going to put that up on top. Then I take that and I'm going to distribute it to everything out in front. So that gets me an x cubed minus 4x squared plus 3x. I'm going to wrap that in parentheses and I'm going to subtract it away. Now I'm going to subtract down. So the x cubed minus x cubed, 0. That should always happen, otherwise I did something wrong. Then negative 6x squared minus a negative 4x squared gets me a negative 2x squared, double negative, so it cancels there. Then 11x minus a positive 3x gives me, that is 8 plus 8x. And then this negative 6 is just going to come down, so minus 6. Then I'm going to see how many times is this number here. If I divide this negative 2x squared by x, I'm left with negative 2, because x squared is going to cancel with all of that x squared, so it's all gone. Then I have this minus 2. I take that and I'm going to distribute it in, and I get a negative 2x squared plus 8 plus 8x and minus 6. I'm going to wrap all of that up in parentheses and put a minus out in front. And actually looks like a lot of that's going to cancel. Negative 2x squared minus a negative. Oh, so that's 0x squared. 8x minus an 8x. Oh, that's 0 x's. Negative 6 minus a negative 6 is plus 6. So then 0. Awesome. No remainder. So I would be even a remainder of 0, which I don't even have to write. Awesome. That means, folks, this x squared minus 4x plus 3, if I were to multiply that x minus 2 back in, I get x cubed minus 6x squared plus 11x minus 6. Awesome. Okay, I really have just factored it because I ended up with a remainder of 0, which is really awesome. I have now this trinomial times a binomial, which is more factored. That's awesome. Let's go on and look at our next example. So here I'm going to set this one up the same way I did last time. Then I still need to see this first term divided by this first term. So 2x cubed divided by x gets me 2x squared. I distribute that in, and I get 2x cubed minus 2x squared. Wrap it up in parentheses, subtract it away. Now I'm going to add straight down. I get positive 9x squared minus a negative 2x squared gets me 11x squared, and then everything else is going to come down. Then I need to figure out this x out in front and this 11x squared. I need to divide those two things. So 11x squared divided by x. One of those x's cancel. I end up with 11x. That's what goes up top. 11x. Then I distribute that into everything out front. 11x squared minus 11x. Wrap that up in parentheses, and I need to subtract it away. And that ends up, this first chunk cancels like it's supposed to. Then 10x minus a negative 11x, which is 21x's, and then the 3 comes down. Then I have this 21, and I need to divide by x, and that gets me just a 21. 21 times all of that, 21x minus 21. Wrap it up in parentheses and subtract it all away. I end up with 3 minus a negative 21 is a positive 24. And that's my remainder, so I'm just going to write that as an r of 24. Or I could write it, cross that out so you don't think it's writing both. Or I could write 24 over x minus 1 because it was not divided by this x minus 1 yet. It doesn't go into there at all. So I still just have to write it like that. Just like how I took all of these other ones, I put it over x. Here I'm going to put it over x minus 1 because that's what all needs to happen. All right. That is, again, done. But I'm going to write this out off to the side. Again, the 2x cubed plus 9x squared plus 10x plus 3 equals x minus 1. If it were distributed then to the 2x squared plus 11x plus 21 plus 24x over 1. Yeah, I know I kind of dropped down there, but you get the idea. Those two things equal each other. Not quite an actual factor here. Not a factor because of this chunk here. All right, let's keep going. Oh, one more thing. This degree is a degree of 2. This degree in here was a degree of 3, and since I divided by degree 1, I should be 1 degree lower. In the last one, here, I was a degree 3, and I divided by a degree 2, which means I should result in degree 1. 3 minus that 2 gets me this 1. Good, I have done it correctly. Let's keep going to our new example. So here we're going to use synthetic division, and this is set up a little bit differently. I first need to fill all of this in with any extra gaps. So it goes x to the 4th, then there's 0x cubes, then there's a negative 25x squared plus 0x's plus 144. So I need to write this in descending order with all of the gaps filled in. And I'm dividing by x minus 4. Now that cannot be 5x minus 4. It cannot be 13x minus 4. Or even a negative x minus 4. It has to be just x plus or minus some number there. Now all of these coefficients, I'm going to take all of them and just list them. 1, 0, negative 25, 0, and then 144. I'm going to put this little half box off to the left. this x minus 4. I'm going to solve it for, I'm going to solve this for x. So x minus 4 equals 0. I want to add the 4 over. So x equals positive 4. That positive 4 is what goes in my little half box. So now I'm actually going to do something semi-simple, I think. I'm going to take this 1 and I'm going to just drop it straight down. Every single time, whatever number comes first comes down. So it's a 1. All right, so once I've drawn that 1 straight down, then it's 4 times 1 gets me 4. I'm going to add all of these rows straight down, straight up adding. So 0 plus 4 gets me 4. Then I keep with this number that's in my special little box, and I keep multiplying it to all of these. So 4 times this 4 gets me 16. And then I add down again. Negative 25 plus 16 gets me negative 9. Negative 9 there. Then I take that 4 and I multiply to this negative 9, and I get negative 36. 0 plus negative 36 is still just negative 36. And then I multiply it again to that 4. So 4 times negative 36 gets me a negative 144. So I add those down and I get 0. This last number is always going to be my remainder. And since it was 0, that means that this is a factor. So x minus 4 is in fact a factor. Let's write all this out. So I had originally x to the 4th minus 25x squared plus 144. So that's going to equal the thing I divided by, x minus 4, and the thing I resulted in. So this, remember I always told you that if I'm dividing by a degree 1, I'm going to be 1 degree less. So now this is going to be a degree 3 that it should be. So I should mean x cubed plus x squared minus 9x minus 36 is just a constant, and then my remainder is the last term. So that's always how it shakes out, especially with synthetic division, because I have to divide by a linear function. So this is x cubed plus 4x squared minus 9x minus 36, 0 remainder. Awesome. So that means this is true. That means this chunk here is a factor. It also means that if this function, let's call it f of x, if I were to plug in a 4, I would get out a 0. And that's what all of this means as well. That goes back to the remainder theorem and the other theorem that was out front. So that is kind of nice and kind of neat, because sometimes this can be easier than plugging a 4 into x to the 4th minus 25 x to the squared plus 144. This could be a little bit easier than that. These numbers don't tend to get very large. All right, let's go on and do another example. So here I'm going to do another example of synthetic division. I'm looking at my coefficients. This one actually isn't missing anything. I go x 4, 3, 2, 1, 0. Awesome. So I'm just going to write those down. Negative 1, 7, 1, negative 2, negative 12. Then I'm going to look at this, and that is how I'm going to find the number that goes in my special box. So what the number that goes in that box is this equal to 0, and I'm going to solve for x. So it's a positive 3. So then I'm going to take this first number, drag it straight down, get a negative 1. 3 times that negative 1 gets me a negative 3. I'm adding these straight down, and that's what gets me a 4 here. Take that 3, multiply it to that 4, and I get a positive 12. Adding down, I get 13. I again multiply those, and I get, 30 plus 9, 39. And add those up, and I get 37. Multiply that with that 3, and that's 90 plus 21 is 111. Add those down, and I get 99. All right, and then from here, I know I have a remainder of that 99. So this is not a factor, but it does tell me that if this function, we'll call it g this time, if I plugged in a 3, I would get out a 99. And that is really good information to know. That can, again, be helpful in doing this. Instead of plugging a 3 into all of that, this can be kind of nice. So let's go on and look at our next example. Alrighty, folks, so a technology company is using the function right there to model expected annual revenue in thousands of dollars for a new product, where X is the number of years after the product has been released. So if X is 10, it's 10 years after it's been released. Use the remainder theorem to estimate the revenue to year 5. There's a couple of ways I could do this. Let's ignore the remainder theorem part right now, and let's talk instead about how I could solve this. So I could plug that 5 in, and just literally plug it into the formula. So negative, and then that's 5 cubed plus 12, 5 squared plus 6 times 5 plus 80. But sometimes this can get pretty muddy. 5 cubed gets pretty large, and then 5 squared times 12, big numbers sometimes. Instead, I could use the remainder theorem, like they actually told me to. And that would mean that I'm putting the 5 in that little box, and then I'm going to list out all of my coefficients here. And they do go in descending order. I'm not missing any. 3, 2, 1, 0 when it goes to my exponents. So it's negative 1 for my coefficient, and then 12, and then 6, and then 80. So now I just have to drop my first one down, negative 1. 5 times that number gets me negative 5. We'll add these two things up, and I get 7. 5 times that 7 gets me 35. Good job. And I add down, and that gets me, 6 times 3 is 180, plus 30 is 210. Then I have 5 times 210, and that is 1,050. And then I have to add that now, so that's 1130. And that right there, folks, that is my remainder, which is also going to be my answer. So the remainder theorem says that if I take that function, Rx, and I plug in that 5, that's going to get me the same thing as my remainder when doing the synthetic division, which in this case is equal to 1,130. And that's in thousands of dollars. So this is actually $1 million, which is kind of nice. So that's this one, and let's go on to our next one. All right, folks, so here I'm going to try and decide and figure out whether or not x minus a is a factor of our function p in this case, which is this one. So to do that, I could do a couple of things. One is I could solve this part for x. So I'd subtract this 5 over, subtract that 5 over, get x equals negative 5. I could plug in that negative 5. I could plug it into every x there and simplify all of that and figure out if it ends up being 0. If it does, then this is a factor. Awesome. Or I could plug it into synthetic division, which is what I'm trying to teach you, and which would be easier to do. So that negative 5 is going to go in this little half box. Then I'm going to lay out all of these coefficients. As long as they're in descending order, I don't skip any. It goes x to the 4, 3, 2, 1, 0. Good, I didn't skip any. So my coefficients are 2, 9, negative 2, 6, and negative 40. The first one always comes down. I get a 2. Then I multiply my special number there with that 2, and I get a negative 10. Adding straight down, I get a negative 1 here. Again, multiply by my special number, and I get a positive 5 this time. Adding down, I get 3. Multiplying to my special number, I get a negative 15. And that gets me a negative 9. Multiplied again by this number. That gets multiplied to every single one of these. And I get positive 40. And look at that, it cancels. I end up with 0, which is my remainder. But that also is p, plugging in a negative 5, it equals 0 because that's what my remainder also does. So yes, it is a factor because my remainder was 0. And if I were to plug that in, I would get 0, which is pretty sweet, folks.